the planet would experience wild climate swings. But when did a planet that looks like the Earth we know begin to take shape? Earth's hot molten surface took at least 1 billion years after the moon was created to cool and form a thick skin, its crust, or so scientists believed. But no one knew for certain because Earth is such a geologically restless place that none of the original crust survives today. Yet startling new evidence is causing a major rethinking of when Earth's crust first formed. The clues to this mystery are embedded within these rocks in Western Australia. Here, geologists have extracted tiny crystals called zircons. About the size of sand grains, zircons are nearly as tough as diamonds. These relics of the early Earth formed when molten rock cooled into solid crust. So the age of the zircon gives you the age of the crust itself. And it was here that geologist Simon Wilde hit pay dirt when he found one crystal so old, he's convinced it was formed in the Earth's original crust.
When we look at the chemistry in detail from the zircons in this rock, we find that it's consistent with having grown in a piece of continental crust.
Radioactive dating shows that the oldest of the zircons Simon Wilde found in these hills is 4.4 billion years old, suggesting that Earth might have cooled and created a crust soon after the moon formed.
We don't know, of course, whether the continental areas were extensive or whether they were just small little islands of material, but certainly what we do know is that there was continental crust at 4.4 billion years ago.
This was just 150 million years after Earth was born, not 1 billion years as previously thought. But that led to another mystery. Once Earth was cool enough to form solid ground, water could collect on its surface. So when did that happen? Geologists, including Stephen Moisish, think the answer may lie in these same tiny zircon crystals. Zircons are extremely rare. So to find just a few crystals, Moisish had to pulverize and sift through hundreds of pounds of ancient rocks. And analysis of the chemical composition of the crystals revealed that the oldest zircons contained a high concentration of a curious ingredient. It was a type of oxygen called oxygen-18, an isotope that could only be present in large quantities if the zircon crystals had grown in water. The news that water might have been present so early in Earth's history was a bombshell.
Not only was there crust present, which came as a surprise to most of us, it looks like, from some of the zircons, that that crust interacted with large volumes of liquid water.
The idea that water settled on Earth's surface so soon is controversial. But if true, it suggests a planet much more like today's than anyone had ever imagined.
By 200 million years after the formation of the Earth, you can imagine a landscape of islands and small continents bathed by a primitive ocean.
The time was only 10 minutes to 1 in the morning. The moon existed, and so did a planet with not just land, but water. Liquid water is the key to life. Every living thing requires it to survive. and eventually water would cover nearly 3/4 of the Earth's surface. In fact, all the world's oceans contain nearly 100 million trillion gallons of it. It's an almost incomprehensible amount. So where did it all come from? How would Earth have ended up with such vast quantities of the stuff? Well, strange as it sounds, these great oceans may have been there from the very beginning, just hidden away. One key to the riddle was volcanoes, which, throughout Earth's infancy, pumped huge amounts of steam into the atmosphere. Then, as Earth cooled, that steam condensed into rain. Drop by drop, water collected in low-lying areas.
There's nothing mysterious or surprising about this. The Earth does it right now. The main gas that comes out of Hawaiian volcanoes is water, steam. So this is happening all the time.
But some scientists argue it would take far too long to create such vast oceans by volcanic outgassing. Instead, Earth may have had some help. The water in our oceans might have come from outer space, delivered to the surface by massive ice-bearing comets. The evidence for these ancient impacts is impossible to find today, since the original surface of our planet has long since been eroded or destroyed. But there's one place that preserves a record of impacts from that early era: our moon.
Every one of those craters was a meteorite explosion at some time. That's incredible. Oh, there's a nice one with fractures, and another bigger crater out here, small craters.
The moon's surface is littered with craters, some of them hundreds of miles across. In fact, the moon was ravaged by more than 1 million major impacts in its early years. Since Earth is much more massive, its gravitational pull would have attracted even more debris, resulting in possibly tens of millions of impacts.
We all hear about the impact 65 million years ago that wiped out the dinosaurs. And you're getting that kind of impact something like once a month on the early Earth. But this rain of debris left over from the formation of the solar system continues for several hundred million years.
And in this cosmic debris field, comets containing huge amounts of dust and ice would have been plentiful. Like dirty snowballs the size of mountains, roughly half their mass was water. One NASA scientist, Michael Muma, wonders if these comets were the source of the water in Earth's oceans.
One possibility is that Earth's water was delivered by the impact of bodies from beyond the Earth. These would naturally be the comets, which are rich in water. The proof in that would be to measure the composition of cometary water and to compare that with the composition of water in our oceans.
But studying comets is a tricky business. In the last 20 years, just a handful have passed close enough to examine in detail, including one in 1997 called Comet Hale-Bopp.
A comet like Hale-Bopp would deliver about 10% of the water needed to fill one of the Great Lakes. This is a lot of water. Of course, the oceans are much larger, and so we need many more comets